going to apply those index laws that we've learned last lesson, and where there's more than one law that will be applicable in a question. So same thing, it's not complicated. Let's get started. Why is that funny? Okay, good. Bad excuse, it isn't. Now, 3 and 4. 3 times 4. Are there any index laws there? No. What's 3 times 4? 12. So the number is simple, just 3 times 4. Now, x to the power of 5, eyes on the board, times x to the power of 6. Same base, x, yes or no?
Yeah.
Yes. And they're being multiplied or divided? Multiplied. So same base, x and x, and they're being multiplied. What happens to the powers? Added. So can I say 5 plus 6? So x to the power of 5 plus 6, which is 11. That's it. So 12 times x to the power of 11. Does that make sense? Next one. Now, we first have to do the brackets. So x to the power of 3 times. Now, what happens when we have x to the power of 4 raised to another power 6? What happens to these two powers? Look at your laws that you've copied. Times. So what's 4 times 6? 24. So can I write this bit as x to the power of 24?
Yes.
Now, are the bases same? X and x? And they're being multiplied? What happens to the powers? Added. So x 27. Does that make sense? Perfect. Next one. There's something in the bracket and the whole thing has been raised to the power of 0. Does it matter what's in there? Anything to the power of 0 is? 1. Straight away. 1. What if I made it a little bit trickier? And another example. What if I had 5 times x to the power of 0? Has 5 been raised to the power of 0 as well now? No. So 5 remains as 5. 5x, doesn't it mean 5 times? What's x to the power of 0? 1. So what's the answer? 1. What's 5 times 1?
1. I mean 5.
Okay, I don't have time to go into that. I hope you all know 5 times 1 is 5. But it's important to know the difference. Does that make sense? Yes? Still pens down, eyes on board. Next one. Again, get rid of any brackets first. And whenever you have a division sign, get rid of it and write the question as a fraction. Remember that. So, I'm going to write it as a fraction and get rid of the brackets. Now, 5 and 2. The powers will get? Times. Yep. So, 5 times 2 is 10. Rather than writing the division sign, I'll write this as the denominator. And what will happen to the power? 2 times 5 is? 10. What am I left with? Don't they get cancelled out and I'm left with 3? Anything divided by itself is 1. So I'm left with 3. Happy? Eyes on the board. Equals. Now, deal with numbers separately and indices separate and the letters separately. So the numbers we have 4 times 6 in the numerator and 2 times 3 in the denominator. Just like you'd simplify a fraction. 2 and 4. Can they be divided by 2? So 2 goes into itself. 4 goes into 2. So 2 goes into 4. Twice. 3 and 6. Can they be divided by 3?
No.
So 3 divided by itself is 1. 6 divided by 3 is 2. What are we left with? 2 times 2, which is 4. And in the denominator we only have 1, right? Now, I'm going to do it in more steps so it's not that complicated. We have a to the power of 6. I need to get rid of this bracket. So 3 times 4 is? 3 times 4 is?
12.
12. Now, I'm going to do it in more steps. We'll do less steps later when we're more familiar with it. Now, same base, a and a, and they're being multiplied. What happens to the powers? Added. So what's 12 plus 6? What happens to their powers? They're being multiplied by themselves. So, yep, a to the power of 9. Yes? Now, these two a's, same base, but they're being divided. What happens to the powers? Minus. So 18 take away 9, which is That's it. So we deal with numbers separately and pronumerals separately. And use all the laws that you can. Next one. Find x if 3 to the power of x is equal to 3 to the power of 7. Now, if I do some working out here, will 2 squared be equal to 2 squared? Isn't that common sense? Will 5 to the power of 10 will be equal to 5 to the power of 10? So what should x be equal to? If 3 to the power of something, it's equal to 3 to the power of 7, what would x be equal to? Isn't that common sense? Because they're equal. So if the bases are the same, powers must be equal as well. Because 2 squared will be equal to 2 to the power of what? What would 2 squared be equal to? 2 to the power of 2. 5 to the power of 10 will be equal to 5 to the power of 10. If I have a to the power of 3, what would it be equal to? A to the power of 3. So if the bases are same, the powers will be equal as well. Is that right? Next one. Now, I'll first use the index law here to combine the powers. Bases are same and they're being times. What happens to the power? Add. So, if I'm to add x and 2, what will I write? X plus 2? Is that right?
Yes.
Now, bases are same. Eyes on the board. Here. Are the bases same? Will the powers be equal as well then?
Yes.
So can I say therefore x plus 2 must equal 6? Can we then solve it to find x? So 2 has been added to x. How do I get rid of the 2? Minus 2 from both sides? And what do we get? X is equal to 4. That's it. So that's 2b. And you've got the rest of the lesson to work. Questions? Perfect. Get on with your work.